So welcome to today's lesson, which is on changing of state. So there are 5 learning objectives for today. Understand that changes occur when a solid melts into a liquid or when liquid evaporates to boil to form a gas. Describe the arrangement of motion to particles in both solid liquids and gases. Explain why heating a system will change the energy stored within the system and raise its temperature to produce that change in state. Know that specific heat capacity is the amount of energy required to change temperature of an object by 1 degree Celsius per kilogram. And then also use the equation delta Q equals mc delta T, where delta Q is the change in thermal energy. So heating and changing of state. So inside a block of ice, the water molecules form or have 2 forms of energy, and it's the same with any form of matter. There's kinetic energy, which is the energy of movement, which we've looked at previously, and potential energy due to the chemical bonds between the water molecules and also between them all, so intermolecular bonding. So together these 2 forms of energy make up the heat energy of a substance. So when you heat ice, for example, the heat usually causes movement within the particles of water. That's the kinetic energy begins to raise. And that means that the temperature of any material, be it you, me, or a block of ice, is related to the average kinetic energy of the molecule. So the hotter something is, the more the particles are moving. So when a substance reaches a certain temperature, we're going to then basically have a maximum amount of kinetic energy. Okay, and then all the heat energy that's being added will be involved in creating more potential energy, and it's going to break the bonds between molecules. Okay, and that changes the state because basically what's happening is you're breaking intermolecular bonds moving between each state of matter. Now the kinetic energy will remain the same, meaning the temperature will stay the same. This is why water melts or ice melts at 0 degrees Celsius, okay, or water boils at 100 degrees Celsius. So even though the substance is being heated, the temperature remains the same during a phase change. So there are 3 major states of matter. There are the solids. Okay, so in a solid particle, the particles vibrate in a fixed position, but they have a closely packed regular structure, as you can see in the image you see before you. So each particle cannot move between each other, and that means that solids have a definite shape and a fixed volume. So then we melt the solid and we get to liquids. Okay, so in a liquid, the particles move in and between each other, in and out. This is known as flow. Okay, and they're similar to the same distance as you would get in a solid. Okay, and again, a liquid doesn't have a definite shape, but it does have a fixed volume. So that means you can basically have a liquid take the shape of its container. And we have then gases. So when a gas is when you heat a liquid, it forms a gas. Okay, and the gas particles move in between each other, and they're furthest apart that you can possibly get. Okay, and a gas takes up the shape and also the volume of a container, and also only gases can be compressed because of the large gaps between the particles. So this is basically a property summary table. So solids have a definitive shape, whereas liquids and gases do not. Solids and liquids cannot be compressed, but gases can. Solids and liquids have high density, gases do not. Solids cannot flow, but fluids like liquids and gases can. Solids do not expand in a filled container, and neither do liquids, but gases can expand to fill a container. And for fixed volume, solids and liquids do have a fixed volume, what gases do not. So then we go to specific heat capacity, the reason why your pie is warm, whereas the inside of the pie, whereas the pastry is a lot cooler. That's where you can hold the pie. Okay, so if you have to raise the temperature of a substance, you must transfer heat, be it from a Bunsen burner or say a microwave radiation. And the amount of heat needed to raise the temperature depends on how much you've got, how many particles you've got, so that's the mass, what the substance actually is, that relates to the kind of chemical bonding it has, and how much you want to increase its temperature by. And the specific heat capacity of a substance is the amount of thermal energy required to raise the temperature of 1 gram of that substance by 1 degree Celsius. Bit of a mouthful there. Okay, so in terms of thermal energy, the change in thermal energy to raise a kilogram of a substance 1 degree is equal to delta Q mc delta T, where delta Q is the change in thermal energy, and that's measured in joules because it's energy. C is the specific heat capacity, which was given to you in the exam. Usually you work out the specific heat capacity of water. Well, it's given to you, it's about 4.2 joules per kilogram per degree Celsius. And delta T is the change in temperature. And that delta just means that you've got a change in value. You see that in mathematics quite a lot. So that's pretty much all you need to know for this particular topic. Next lesson, we'll be looking more in depth at the nature of ideal gases.